There's some numbers here I want to fill out, so I want to work out what 10 is. What's 10? It's equal to 1 using the formula, or you can use a calculator. So if you use a calculator, you do 1C0, 1 shift divide 0, which takes long to press, so you just work out by the formula. What's 1 equal to? 1. Let's go to the next row. 2 0 will be 1, 2 1 will be 2, 2 2 will be 1. Yep. How about 3 0? 1, 3 1, 3, 3 2, also 3, right? When it's 1 or 1 less from 3, it's 3. How about 3 3, 1? What numbers does it remind you of? Yeah, so now we have a connection with these numbers while we learn these things. So let's complete the rest. What do you observe? They are the numbers of Pascal's triangle. Okay, good. So what I want you to do is complete the rest of the row. So the next row, you're going to write 4 0, 4 1, 4 2, 4 3, 4 4. Okay, work out what they're equal to. See if you still work for the next row. Page 11. See what they get. So we know the first one and the last one must be 1. These two are both 4s. The middle one you can use the calculator. 4C2. 4C2. You should get 6. Okay, so we get the numbers. I'm going to continue on the next row. 5 0, 5 2, 5 3, 5 4, and 5 5. Okay. And see if we get the same pattern. So we know the first one's 1, the last one's 1. This is 5, this is 5. You just have to work out the middle two using the calculator. 5C2, 5 shift divide 2, you get 10. And by symmetry, that should be 10. Because 5 2 is same as 5 3, right? By symmetry. Now, how about the first one? First one, you just write 0 0. That should be 1. You can double check on the calculator. 0C0. She gives you 1. Okay, good. We should get the Pascal's triangle. So what I want to do is, example 9 is to expand this using the Pascal's triangle. So you'll use these numbers. You'll use the numbers 1, 4, 6, 4, 1 to expand. So let's expand this. So you write 1 plus 4x plus 6x squared plus 4x cubed plus x power 4. Like that. So basically I've used the numbers that I just highlighted. Okay. 1, 4, 6, 4, 1 to expand 1 plus x power 4. 1 plus 4x plus 6x squared plus 4x cubed plus x power 4. Okay. Now, I also want to expand using this notation, the NR notation. So what I want to do is the first term you write 4 0, right? Plus 4 1x. Instead of 4, 4 2x squared. 4 3x cubed. And 4 4x power of 4. And immediately you will recognize that there's a connection between this number and the powers of x. Right? That gives it a convenient system of working out a specific term. Because there's a connection, direct connection between the numbers at the bottom and the powers of x. Okay. In addition to that, I want to practice using the other notation, the 4C0, the C notation. Because you need to be able to use both, depending on what the question uses. So 4C1, 4c2x squared, 4c3x cubed, 4c4x power 4. So that gives us a fast way of expanding any binomial expression. Okay, good. All right, good. Any question? So after we do this, after being able to expand this, now we're going to introduce you the general formula for binomial theorem. So what's the general formula? That's on the next page. So go to the next page. All right, hopefully I'll finish. All right, okay, let's move on. Okay, in general, this generates a polynomial of degree n in the variable x. The nk and the nck refers to the coefficients of x power k for this expansion. So in general, the x power k term, this is the term refers to the x power k term. And now we'll have a general formula for any powers of n. When we expand this, the first term is n0, n1x, n2x squared, etc., which can be condensed using the sigma notation. So let's work out this expression. So I want to find out what x cubed term in this expansion. So what you do is this. You can work out the x cubed term must be 5, 3, isn't it? Because the 3 corresponds to this number at the bottom, 5, 3, x power cube. And you can do that on a calculator. So what's 5, 3? You go 5c3, which is 10. So you can work out the term without expanding everything else. You can work out a specific term without expanding every single term. That's what the binomial theorem about. You can use the formula to work out a specific term of expansion. And that makes it even easier even for any power. So even for a big power, you have to expand everything. Find the x power 6 term. What would that be? It's going to be 8. And what's the bottom number? Must be 6, right? Because say x power 6. And now you can use the calculator to work out what the coefficient is. So you do 8c6 equal 28 without drawing the whole Pascal's triangle. Because I could work out any numbers on the Pascal's triangle using this formula. Alright, so now we've done some of these. Let's do a harder one. Slightly harder. You have a negative. Well, that's pretty easy because all you have to do, you write 7, 1, but you write negative x instead of x because it's negative to the power of 7 or to the power of 1. So now you know 7, 1, you don't have to use the calculator. 7, 1 is just 7. So it's negative 7x. So you can work out very quickly. Alright, now as you can see, this has a lot of limitation because it depends on the first term is 1 and then plus x. We want to have a more general formula. Okay, what if it's not 1 plus x, it's something else? So what we do is on the next page, we're going to work out a general formula like this. 2 plus 3x power 5. So let's expand this using the Pascal triangle. So remember, the numbers are 1, 5, 10, 10, 5, 1. Like that. Let's expand this. So what I'm going to do, let's write it in green. 1, 5, 10, 10, 5, 1. Okay. And then what I'm going to do is to write the term. So you start with 2 to the power of 5 plus 2 to the power of 4, 3x, and then 2 to the power of 3, 3x squared, and then keep going, and then you got 2 to the power of square 3x cubed, and then we get 2 3x power 4, and the last one 3x power of 5. Alright, so I just want to expand this. You don't have to simplify, just expand it. We just want to see if there's any formula we can create. We expand it using the Pascal's triangle. And then what I want to do is, instead of writing the numbers 1, 5, 10, 5, 1, replace it by 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. Okay, good. So I want to write 2 to the power 5, 2 to the power 4, and then 2 cubed. So writing exactly the same thing, except you replace the coefficient by the notation. Alright, okay, good. So that's what I wanted to do, just that at this point. Just write it there and see if you can make any connection between the numbers here and the numbers there. Okay, any connection. Actually, the square is in the wrong place. Okay, good. Hopefully you can see any connection. Now we can see that the numbers here, the 2 refers to the powers of the second term, right? See, these two matches, 3 and a 3. But the first one doesn't match. But there is a formula to match them. See how the 4 is created? You do 5 minus 1. See how 3 is created? You do 5 minus 2. Right? So now we have a formula that calculates any term. So in general, if I want to expand a plus b to the power n, it's going to be nk as we expect the coefficient, but the powers of the a is n minus k. Like we did there, right? 5 minus 1, 5 minus k. And this one is the same as this one, k and k. So that's the formula I want you to remember. We'll just double check it whether it's on the formula sheet. Yep, it's on the formula sheet. So they express it in this way. So on the reference sheet, they write it like this, which is this thing. That's what they have on the reference sheet. How come they have 2 versions? Okay. Okay, use the second version. Because on the reference sheet, they write it like this. They write this as equal to k0. They interchange them. And k, they wrote ak beta n minus k. I prefer you not to use the first version on the reference sheet. Just use that. Just make sure this k match with this k. And you got the n minus k. Okay? So not to use the first version of the reference sheet. Use the second one. I think that's more accurate. Okay. Okay, good. So it's on the reference sheet, which is good. So now we just need to know how to use it. So let's highlight this formula. That's a very important formula. Okay. All right. So now we can calculate any term of a binomial expansion. Okay, so we're not going to prove this using combinatorics. That comes later on in the topic. We just need to know how to use the formula. Okay, we're going to find x cubed in this expansion. So your first step is to write this thing first. That's all what you always do. So you write tk equal 4k 3 to the power of 4 minus k 2x power of k. That's the first step. Write down a general formula. After you write down the general formula, then you look at the question. It says x cubed. So clearly, k has to be 3 for that to become x cubed. So let's calculate T3. 4, 3, 3 to the power of 4 minus 3, 2x power of 3. That calculates the x cubed term. And then you can work out on a calculator. This just becomes 4 that becomes 3. That's 8x cubed. So what's that? 12 times 8. 12 times 8, 96. So what you need to do is, therefore, coefficient of x cubed is 96. Yep. So your first step is to write the general formula first. Okay, make sure you do that. And we'll have lots of questions for you to practice. You'll get these questions in the exam. Of course, not as simple as this. We'll get to the harder one later on. Let's do more questions. Okay, next page. X squared term. Again, you need to write TK first. That's your first step. TK. What's TK? Will be 12k. Remember, take the highest power, 12, and then you do 2 to the power of 12 minus k, and then negative x to the power of k. Okay? Then you decide, obviously, this has to be 2. For that to work, you want the x squared term. So write t2 equal 12 2, that will be 2 to the power of 10, negative x squared. Right? And use your calculator. 12c2. 12c2, that will be 66. Without drawing the whole Pascal's triangle, it's going to be a very big number. Sometimes they just ask you to leave it in index form, or you can just work out. I don't think it's that big. 10. Okay, 67584. 67584. Okay, that's it. Now, be careful. Some questions say, work out the coefficient. This time, they didn't ask for coefficient. They want the term, which means you write the whole thing. So note the difference. They want the term, you write the whole thing. Whereas before, they want the coefficient. Therefore, you write down just the coefficient. Right? Coefficient, 96. Okay. All right, try the next one. All right, find the x power 4 y squared term. So again, you need to write tk first. Write down what tk is. All right, yep. So you do exercise 5D today. Yeah. All right, what's this? So you go 6k, and then you go x power 6 minus k to y to the power of k. And if you look at this, if I want x power 4y squared, clearly k has to be 2 for that to work, right? So let's find t2, 6, 2, x power of 6 minus 2, which become 4, 2y to the power of 2. Just use a calculator. So you do 6c2 times 4. You get 60. So you get 60 x power 4y squared. Done. All right. All right, try the next one. Next one, say third term. Be careful. Third term is not T3 because it starts with T0 as your first term. T1, T2. That's the third term. So find T2. So find TK first, then T2. So it will be 8K, 3x power of 8 minus K. Then you do 2y to the power of K. And then substitute 2 in. 8, 2. What would that be? That will be 3x power 6. 2y to the power of 2. And then you just work it out. So 8c2 multiplied by 3 to the power of 6. And then multiplied by 4. Get a big number, 81648. 81648, 81648, x power 6y squared. Okay. Alright, and then we'll keep doing. So constant term again, write tk first. So by now, you should be able to write this confidently. 4k, 3 to the power 4 minus k, then 2x power of k. Okay. Now they want the constant term. Constant term means the powers of x is 0. Okay, that's the constant term. So therefore you put k is equal to 0. So let's find t0. Alright, so you get 3 to the power 4, which is 81 times 1. So it's 81 is the constant term. Okay. Alright, go to the next page. I've got 2 more pages, then we're done. Okay. Alright, all ready? Alright, try the next question. F. Okay, alright, next one. Again, write tk first. Will be 7k, x power of 7 minus k, negative 1 to the power k. You want the x squared term, you may think, is k equal to 2? In this case, no, because this is the part you want to make it equal to 2. Alright, so you've got to be careful. That's why I always want to write the general term first, because k may not always match with the power. So 7 minus k is 2, negative k is negative 5, therefore k is 5. Okay, let's put 5 in, t5 equal 7, 5, x power of 2, negative 1 to the power 5. Work out what 7, 5 is on your calculator. 7c5, you get something. 21, so you get negative 21 x squared. Like that. Alright, good. Next one. Find the coefficient of x cubed in the expansion of this. Okay, so again find tk first. You do 7k, 2 over x to the power of 7 minus k, x power of k. Alright, now you want x cubed, but be careful, k is not 3 because there are interaction between this x and this x. So you have to do some work. This is more like an exam style question. You have to do some more work. So let's simplify this. So to simplify, you write 2 to the power of 7 minus k, x power of 7 minus k, x power of k. So that's the first step. And then you have to combine these two. How do you combine them? Use index law. When you divide, you subtract the indices. So you subtract k by 7 minus k. Note the use of bracket. Note the use of bracket. Okay? So you separate the coefficient from the pronumeral. That's the key. Coefficient and the pronumeral bit. Separate them. And then you work, then you do more work. So pronumeral. So what do? You have to simplify it. So we keep going. 7k, 2 to the power 7 minus k, x to the power of k minus 7 plus k, because of the bracket, the double minus become plus. And you keep going. 7k, 2 to the power 7 minus k, x to the power of 2k minus 7. So that's the key part you write it in. Then you say, the question asks for the x cubed term, therefore this thing must be 3. So it becomes a simple linear equation you solve. 2k is 10, k is 5. And there's no way you can guess that right. So you have to do all of the algebra. So let's substitute 5 into either the initial one or this one. Okay, so they want the coefficient of x cubed. So you can now work out, therefore, coefficient of x cubed is 7, 5, 2 to the power 7 minus 5. because you got the coefficient part, right? So what's that equal to? 75, you can use your calculator. Oh, I've already got it there. 21. Okay, 21 times 4, 84. Like that. Okay, so an exam type question will have a question on this, maybe worth about 3 marks, because as you can see, it involves a lot of working. Can you try the next one? H. Determine the dependent of x. Okay, so same step, just write TK first. Have a try. Alright, let's try this. Okay, your first step, hopefully you all had a try, so it's very good. So TK equal to 7k 2 over x squared, 7 minus k, negative x power 5, power of k. So do each step slowly. So you separate the coefficient from the polynomial, 2 to the power 7 minus k, including the negative one, that's a coefficient, like that. And then you do, yep. Alright, let's continue. You go 1 over x power of 2, 7 minus k, x power of 5k. Right, so make sure you do each step slowly, not to skip step, because you could make a mistake, because there's a lot of things involved. So you do things step by step, like that. And then you go x power of 14 minus 2k. Minus 2k, and then you go x power of 5k. Okay, like that. And then we'll keep going. 7k to the power 7 minus k, negative 1 to the power k. And then you do this, x power 5k minus in bracket this thing. So you go 14 minus 2k, like that. Notice I took a lot of steps, putting a lot of details in order not to make a mistake. I do each step, because if you missed out something, you will be wrong. Okay, so make sure you show all the steps. What would that be? That will be 5k plus that will be 7k minus 14. Perfect, that's all we need. So now what do? We need to find the term independent of x, which means the power of x must be 0. And that's easy to see, k must be 2. We found it, which is the constant term. So therefore, now we've got this bit. So what do? We say constant term, or the term independent of x, is P2. 7 to 2 to the power of 7 minus 2, negative 1 to the power of 2. What would that be? Use a calculator. 7 2 is, should be 21 by symmetry. 21 times 2 to the power of 5 times 1 to the power of 5 is 32. Yes, 32 times 21. 672. Hopefully you all got that. 672. Yep. Everyone got that? Good. So that's a very complicated example. But I want you to study that carefully and practice doing this. Okay? Alright. Now one more question to do. That's a harder one. See if you can work it out. So a harder question may involve 2 expansions. Okay. Alright, let's try this one. I. Okay, next page. Let's do that. If you're ready. Okay, good. Thank you. Alright, let's move on. Next page. Find the x power 4 in this expansion. So what you do is this. Your first step may be to expand this. So I'm going to expand it using 5, 1, 5, 0, plus 5, 1, 3x, plus 5, 2, x, 3x squared. And what else are there? 5, 3x cubed, 3x cubed, plus 5, 4, 3x power of 4, plus 5, 5, 3x power of 5. So how do I get the x power 4 term? To get the x power 4 term, you have to expand 1 times this and x squared times the x squared term, right? So right therefore, x power of 4 term is 1 multiplied by 5, 4, 3x power of 4 plus negative x squared multiplied by 5, 2, 3x squared. Like that. And then if you simplify, we'll know that equals to 5 times 81 x power 4 minus, that will be 5, 2 will be 10. 10 times 9 is 90. 90 x power of 4. And what would that be? Use your calculator. 5 times 405 minus 90. That will be 315. And you can write therefore coefficient of x power 4 is 315. That. Now the question is there a shorter way? Well, once you see the expansion, there is a shorter way. As you can see, I don't have to expand every single term. I could just expand the one I want. So if you want x power 4 term, first you're going to write down the general term of the second expansion. Let's write down the question again. 1 minus x squared, 1 plus 3x power 5. So you write down the general formula, which is tk equal to 5k 3x power of k. So therefore, to get the x power of 4 term, what do? You do 1 multiplied by t4, right? Because that has to be 4, plus negative x squared multiplied by t2. So you can cut down the unnecessary work. But if that's confusing for you, you can just write everything, just to be safe. But if you feel you're confident, just do it straight away. It's allowed in the exam. So you go 1 times 5, 4, 3x power of 4, minus x squared, 3, is it 2? 3, 2, 5, 2, 3x power 2, etc. Okay, you should get 315 x power 4. Okay, so that's method 2. Alright, I leave the exercise to you, so please complete exercise 5D today. The questions are on the booklet. Okay, good. Alright. So file, I'm going to save the video. So you can start